Hello, everybody. Welcome to the Juju Show number 23. As you can see, people are away at sprints this week, and therefore it is a small house. But we got some fun stuff to talk about. We have the next step from our beginners lessons that we kind of had last time. But first, the community news. What's been going on? Well, there's big shakings and rumblings in the Juju world because the Juju 2.3 release is starting down the tracks, heading down towards final release. The team has released a beta 1 that you can get from the snaps. And if I check, I believe the snap, it's in the actual beta channel, and you can also grab it. I have to double check whether it's from the Deb or the PPA or not. But I recommend grabbing the snap, trying out the beta, giving it a shot and seeing what's in there. There's a bunch of new stuff in there from cross-model relations, persistent storage. There's some work around using the fan for container networking. So there's a lot of great stuff in there. Documentation's on the way, getting written up. And we'll be showing off some of that as it goes throughout the beta process. So right now, this team is saying they're going to try to commit to a beta every week until they hit RC. So the last beta hit, I believe, at the end of last week, last Friday. So look for beta 2 is coming up Friday. We'll see how that goes. So as always, test early, test often, test with as much as you can. The more you can try to test and hit, the better we'll be at finding any kind of unexpected issues and bugs, and getting them all worked out well before everything hits GA. So I encourage everyone to go give that a shot. And the release front news, the team's also released the charms.reactive 0.5. And so if you're using the reactive framework in your charms, make sure you go update. It's got some updates to it, in particular around something people are a big fan of, which is renaming state to flag, and they're deprecating the state name. So this is an update that may require some changes and things to your charms, but definitely worthwhile to keep up to date. And the move to flags is definitely something that I know that most folks that are writing charms are a big fan of. It helps really clarify and make the charms read a little bit nicer. So go get your updated reactive framework in your charms. And next up, I want to talk about a thread on the mailing list, which I have found really interesting. And the conversation there is around Juju's vSphere support. Juju has had vSphere support for a little bit. It's kind of gone from kind of rough around the edges to getting smoothed out. And I know the team's got a lot of updates in 2.3 to help smooth it out even more. What's been really good is that, the team did the vSphere support because they kind of saw that it would be useful. People use vSphere in their company. It's kind of the cloud for people that don't yet have they don't have an OpenStack or a MAS or whatnot, but they have, a bunch of hardware internally. And so but there wasn't a direct, it wasn't like one person or a company or whatever, like, hey, we need this. And so therefore they would use it. And we had good feedback and engagement with an array of customers. And as the releases have gone by and it's kind of, started out rough around the edges as people have used it, we've managed to smooth those out and to find some things that can be improved upon. And so it's really good to bang on this stuff and provide that feedback. It's been really vital. And so obviously the thread started out with kind of a frustration in that it didn't work in their particular environment. What was very satisfying to myself was others saying, well, it's gotten better for me and it works for me. And there's a whole array of, what people are actually running. And it's a really interesting thread to go through. And what I really wanted to do was just kind of draw more attention to this, that vSphere supported, get more users involved, get more testing of it, more, going through what the actual real scenarios are. And then just to, make sure folks are aware, it is, the email thread is kind of is it deprecated before it's ever born? And the answer is no, not at all. It is definitely just a growing, something that's growing over time, getting smoothed out. So if you have some vSphere and it's be worth playing with some Juju on it, and it'd be a great thing to test the 2.3 betas and see how that experience has improved and provide some feedback on it, because we love the feedback. And finally in the news, I love this. We have our kind of beginner question of the week. And this time the question was someone who was very much trying to script from the CLI against Juju models, but they were having trouble because they were trying to switch between them in order to issue commands. Like, how do I do this more efficiently? And you got to love when people ask questions and you're like, I have an answer for you. And the answer is the -m flag. Almost all of the commands that operate, shouldn't be almost all, it should be all the commands that operate against a model take a -m flag. And the M just says, do this on this model. So you can Juju status and add a -m and put the name of the model on there. And that will help you run status just for that particular model. It doesn't have to be the one you're active on. Same thing with, deploy, upgrade model. It's just great for scripting your upgrades as you upgrade your controller and then go through and upgrade your model, scripting against the model names. Anything you can think of and do, you can do it with the -m flag. And not only will it do it for the model, but because you can have many controllers, you may have controllers on multiple on AWS or GCE or OpenStack or whatnot. The model name can actually be a controller : model name. So that syntax will let you say that I want this model on that controller. And so you can really script across a breadth of Juju deployed infrastructure in a real nice and clean way. And it's great for those kind of automated scripts and things. And if you're doing those, you can help, pull together. You can easily see someone writing up a quick script that takes as arguments the controller to which to perform this. And then that script can go through, list all the models, concatenate the controller model name and perform a bunch of actions in a consistent way across every model on the controller or whatever. So definitely give that a look. That stuff's available in the help for most of the commands. Just look for the -m flag there and give that a try. And hopefully that'll make some of your scripting needs a lot smoother and easier to do. So thank you very much, Akshat, for that great beginner question that hit the mailing lists this week. And that brings me to our main topic. So last time we talked about kind of the beginner vocabulary around Juju. Like, what is a model? What do we mean when we say cloud? What do we mean when we say controller, and so on? So if you missed that, go back and listen to it, or there's a blog post that I put up that's on Insights as well, and I put on the mailing lists to go and kind of go through and start with that. So because it's always best if we're all starting speaking the same language. The next thing I want to do, though, is talk about something else that I feel like we gloss over a lot, but for most people coming in, they care a lot more about. I think sometimes people come into Juju and they're like, wait, but I don't understand. There's nothing here that talks about machines. Everything I do, if I want to use a config management tool, I have to go set up and seed my machines with the agents for those tools, or SSH access and all this kind of stuff. And in Juju, we tend to gloss over that. We just say, deploy this application and things magically happen. And I think it's because we come at things differently. We come at them, we like to kind of think of it as like the next level abstraction, where we're thinking about applications and such much more about the actual physical machines, especially in a cloud world where machines are just requested, over the APIs that the clouds provide. For us, it's kind of focus on your workloads, not so much on the actual hardware. That's kind of inconsequential for the most part. Which hardware you're on, there's how many of them you're using or whatnot. All that's just kind of there are times where that is a little bit different. MAS are kind of abstract, are a layer on top of your bare metal hardware, your racks of servers that provides that cloud API to Juju. Surely if you're buying the actual physical machine, sometimes people buy different machines for different purposes, but for the most part, you basically go, hey, deploy this thing. Now, that doesn't mean that all applications just need the same amount of hardware capacity. There are obviously different instance types in all the clouds. And so what Juju has is a language of what's called constraints. And I'm going to switch over and screen share here to my, I have too many windows. Which one do I want? This one. So in here, I have what we call constraints. And constraints is the vocabulary, the term we use to represent specifications for the actual underlying hardware. The VMs that come up or the machines you get, what they actually are and do. And the simplest version of this that I think we should start with is just deploying something. My command line here. It's just to deploy something. Deploy Postgres. If I were to deploy Postgres in my model here and let it go, Juju is made to kind of work with same defaults out of the box. So notice I didn't tell it what kind of machine I wanted. how much memory I needed, what instance type I wanted, what size disks or whatever. Juju just has kind of a baseline default that it leverages in order to make things like this work, because most tools you prototype and test and check in much more than run in production. And production's where you get very specific requirements for running. So let's say I was going to deploy this for production. I'm going to deploy it, and I want it to have more mem. What I can do is pass value to this constraints flag, and I can specify how much memory I want. So let's say I want to say that instead of the default, which I happen to know gets me around 2 gigs of RAM, I can specify that I want 8 gigs of RAM. And this will actually then, nope, sorry. It's helpful if I remember how to use a command. So I'm going to deploy PostgresQL again. And as we noted in a previous beginner question, I can specify the name of it so that they don't collide, right? I already have a Postgres from the last command. So this time I'm going to have a second one that says more memory. And this is going to go through and deploy and give me another machine. As that machine gets requested from the cloud, Juju's going to look at the map of instance types and go, what's the best, most cost-effective way for me to get 8 gigs of RAM out of this? So it's going to look across all the different instance types, whether they be T's or M's, or in Google's, they've got the kind of, N1 standards or high mem or whatever underlying provider you're on, and going, hey, how can I get 8 gigs of RAM? I don't really care about the rest of it. Just give me that. And Juju will help you pick the right instance type. And so I'm going to cheat. I'm going to have one already here already. So ignore this prod one at the moment. But here you can see the original one, it's allocating the machine, and then the more mem, these are on machines 1 and 2. And I can see what's going on by using show machine. Juju show machine will give me the details of the machine. So the first one I deployed without any special arguments, got me 1 core, got me almost 4 gigs of RAM, and a disk that's around 8 gigs big. And that's about it. So when I go look at the next machine, the one where I said, hey, I want 8 gigs of memory, notice I have 2 cores and 15 gigs of RAM with the same 8 gig root disk. And so what's interesting here is I asked for 8, but I got 15. And this is a case where instance types kind of matter. I have another model where I've done a bunch of these different constraints already. And let's go switch over to that. I can walk through a few different scenarios. Here we go, show constraints. All right. Looking here, I've got a whole bunch of different Postgres that I've deployed because it's a great one to play with. So let's see. The first one I've got is this constraint here. So let's Juju show machine, and that is machine 1. This is one where I specified I wanted 32 gigs of RAM. Now, if I go and I look at the actual available instance types in GCE, there is a 30 gig instance type, which is too small because I asked for 32. And you can see the constraint here. I asked for 32 gigs of RAM. The next thing it could do is it went and found me a high memory instance that has the 52 gigs of RAM. That was the next available one. It ended up getting me 8 cores. It ended up getting me, by default on here, I've got a 10 gig disk. So if I want something, what it's really allowing me to do is focus on the needs of my application. How much memory does this Postgres need to run and operate properly? And I don't hard code in an instance type that isn't compatible anymore. This allows me to take my model. My model says Postgres must have 32 gigs of RAM, and that model can be applied on any cloud that I go and take it to. Be it an internal MAS, it'll find a machine in MAS that has 32 gigs of RAM. If I ask for it on Google, AWS, GCE, OpenStack, no matter what, it will go and find some instance that has at least that requirement. And that way, when I run my Postgres, I'm assured that it will meet the expectations of what I'm trying to operate over time. So other things we can do, other things that we can kind of constrain against is cores. So let's look at machine 2. I look at machine 2, you can see in this case, I said, you know what? I want my Postgres to have 4 cores available as far as CPU goes. And here it went and found the smallest, most cost-effective instance type that has 4 cores, which in this case has 3 gigs of memory, and that's about it. Now, obviously, the one that's interesting is the root disk. And so I'm running a database. Databases need space to store things. So really, one of the things I should always do whenever I run Postgres is to specify how big of a disk I want to have. Now, in this case, I actually use, actually, let's search this way. Here we go. This one, when I deployed this pgsql big disk application, I said I wanted the root disk to be 1 terabyte big. Now, Juju, fleshed that out, lovely conversions, and went and noticed that I have the same default instance type. I have 1 core, I have 1.7 gigs of RAM, but it sized the disk to 1 terabyte so that even though I don't have the most performant machine, I've got the space for all the data I want to have on it. Now, obviously, I wouldn't run a production Postgres with less than 2 gigs of memory and 1 core. That's not going to be a great Postgres to do a lot of stuff with. So what we really want to do is to go through and do a production level Postgres where we would combine the constraints. And notice I have to quote them here because there's these spaces in the value of 4 cores, 24 gigs of RAM, and a root disk of 1 terabyte. Now, this is a case where I now have a really kind of proper sized Postgres that I can envision running for my corporate needs, for cross teams, multiple databases, doing a bunch of work. And that will go and find the right instance type that has all these requirements. It's going to find out which instance type has 4 cores, has at least 24 gigs of memory, and it will size the root disk at 1 terabyte for me to stick my storage on. And because we default to using a persistent store volume on basically all the public clouds, and I think even on as much as we can, basically, that storage is reasonable storage to use. It's not complete transient stuff that I wouldn't stick ephemeral disk like that you may have used in the past. So this is kind of the language about how Juju allows you to kind of stick it kind of above the fray, modeling things based on what you actually need, and let the realization of those needs be handled by Juju itself, dependent on where you apply this. Now, I will say, Juju does support a constraint where you specify the instance type as the flag. So I can Juju deploy, Postgres constraints and do instance type equals, and I can spell out the name of my instance type that I want to have. But we generally encourage people to stay away from that, because at that point, this model is no longer easily translated from cloud to cloud to cloud, or maybe different clouds. So if you have an OpenStack, for instance, there's something that says the 2 OpenStacks have the same instance types available, same flavors available in them. And so anytime you get into this business of hard coding the instance types, you've definitely kind of limited your ability to have that flexibility in mind in your model. There are times where that's necessary. So in MAS, for instance, there aren't really instance types in MAS. You've got your hardware registered. What people often do is they tag their hardware. So if they have machines specifically designed for storage purposes, they may tag them storage. And then if they have them for, compute purposes, and they've got some really, crazy 8 CPU, multi-core instances, those may be, high CPU or something, high memory. And so then what you would do is you would use tags as the constraint to target those. So I could say deploy Postgres where a tag is, storage. And that'll guarantee me I'm on a machine that has a lot of disks if I want or need that. So, I mean, sometimes you can't help it, but for the most part, the constraints mechanism is very much put together in a way to try to help you stay as translatable and kind of agnostic as possible. And if you go through and then dump stuff out, so let's go back to my browser window here. And it's the one that has the constraints documentation in it right now. So if I go, this is the GUI running on that GCE instance. Actually, I did that in Jazz, so it's actually in Juju Charms. And you can see all the different Postgres I deployed. I deployed an original one with just default, a 4-core where I specified 4 cores. The constraint is actually where I first said I want 32 gigs of RAM. The big disk is the 1 terabyte, and the prod is all of them put together. And what's cool here is if I go through and export this, and this isn't going to work because now I need to stop sharing this and instead share the editor that shows the resultant YAML in it. So switcheroo again. All right, so here we go. Here I have the kind of the bundle that would be dumped to this. This is the representation of my model. And you can see how the machines vary depending on which machine it was. So this one has 1.7 gigs. This one has 52 gigs. This one has 4 cores. This one's got the big root disk. And then this one has 4 cores, 26 gigs of RAM, and the 1 terabyte disk. And so machine 4, we can pretty much guarantee here is the prod version of our Postgres. So because we can now export this with the constraints, we can make sure that if we were to take this and deploy this YAML, this bundle YAML onto AWS, we would get different instance types, different names, but they would meet the same characteristics that we need to have a productive Postgres instance going. So let me check, are there any questions in IRC? Nope, it is a quiet day today. So we'll have a blog post that kind of walks through this with some copy and pastable examples and some screenshots and stuff that I'll have on the mailing list and on the Insights, Canonical Insights blog. But hopefully that gives you a little bit of an understanding of where the machines and the information about machines fits into Juju world. You definitely don't start with the machines. You kind of start with the applications, the stuff you're going to operate. And machines are kind of just a byproduct of getting that up and running so that you can operate it over time. If any questions or anything, don't hesitate to ask. Hit us up in Juju channel and IRC on Freenode, on the Juju mailing list, or you can personally ping me on Twitter at mitechie anytime you like. Thank you very much. Goodbye.